And we can continue with the questions if you like.
Yes, since approximately 1850, 1875, the days of Maxwell, Henry, and Faraday, the electromotive formula has been written, I is equal to E divided by R.
Yes.
Your device clearly suspends the balance of that equation. My question to you is, how would you rewrite the equation to explain the excess energy that's being produced by your device?
If you read the early printings from Cavendish Laboratory in England, the people there were connected with Maxwell, and if you read the books and the printed material that was occurring at the time that Thomson did his work on the electron, and that Hertz did his thing, and the other people, you'll find that Maxwell actually didn't think the way that he's presented at this time. That Maxwell, actually the thinking of Maxwell is almost exactly what I've been telling you in my written material. So what Maxwell supposedly, what they put in shorthand form to illustrate what was happening, was very much in doubt at the time that it was done. There was serious doubt, and I can show you in print where a number of people who were headmasters for in Cambridge, who wrote the books and things at the time that Maxwell was coming along, expressed serious doubts about the shorthand methods of which things were presented. Okay, we need some more questions. I'm sure there must be a lot more. It's going to be difficult for me to respond to you once we get away from here because of the number of people that I see. We have some new light bulbs. That's perfectly fine.
Yes, sir. Is that okay if we hook them up?
Yeah, why not? Why not? I'll be glad to burn your light bulbs out. I had some back of the thing here. You didn't have to go get them.
These are 100-watt light bulbs?
These are 40-watt light bulbs. Sylvania, 140 volts.
I tell you what they are, because what you're fixing to do is burn this man's camera out over here.
I hope not. I hope not.
That's exactly what you're fixing to do. Because unless he's got a shield on there to protect it, when this thing comes on, your camera won't be much use after that. Do you have some kind of filter that you can work with? Because this thing is going to knock your camera out. It's going to knock your camera out when I turn these lights on.
We can bump it.
Do what?
We can turn it down.
Okay, well, watch it, because
Okay. Thank you, sir. I'll hook my meter up to you.
okay. Okay, you want me to turn it around or what? Okay. He wants you to move back so that he can take a picture of it. Now what I'm going to do is kind of tilt this sideways a little bit so that he's going to be able to see. If you're hooked up?
Ready.
Okay. What you read?
Little drop in voltage is about 64 volts, 65 volts, which translates to something near about 100 on the AC, and it's taxing it a little bit.
No, it'll correct itself.
It will? Yeah, it's coming up. 668.8. Wow.
Are you impressed? Okay, what's it reading now?
It's 68, still holding steady.
It'll come up. It eventually will come up to about 112, maybe.
No, this is calibrated for sine wave.
But you have to correct this reading, which he's got, because it's reading a different method.
Any other questions?
Yes, sir. I can be answering questions while this is going on.
Okay. You mentioned that there's a battery in the suitcase unit that's being recharged by the power from the system.
Yes.
Could that battery be replaced by capacitors?
Yes, in part it really is, because what's it doing?
Frequency is still steady at 60 hertz. Voltage is dropping, though. I don't know if I want to keep on going. I don't want to burn up the suitcase.
It's not going.
Are you sure?
The circuit in here will start heating if it's overloaded.
Okay, it's hard. The voltage is dropping. It's down 58, 61, 62.
Yeah, I may have to do some adjustments on it.
Okay. Good. Thank you.
Okay.
Yes.
Feel more comfortable now? Okay.
It turns out that, could I explain just what we did there?
Yeah, sure.
With the 100-watt light bulbs. Sure.
We've got basically 1,000 watts there going on.
Right. With 1,000 watts of light bulbs there, that 12-volt battery inside the suitcase would have to put out about 83 amps of current. I don't know, have anybody taken a battery about that big and drawn 83 amps out of it? You can only do it for a very short period of time. We were running over 3 minutes with that, and there's no way that that battery could do what we just saw. But it did it. Thank you, Doc.
You're welcome. Yes, sir.
Yeah, my question about the capacitors, by replacing the battery with capacitors.
Well, actually, the two things do somewhat the same thing. A capacitor and a battery serve somewhat the same purpose. A capacitor actually does it better than a battery.
So it would be possible then to just replace the battery with capacitors?
In power correction systems, it's a capacitor bank, and if the power goes off, the energy is there, and it continues on even though the power is off. Yes, sir. I think we need some more questions. You're going to take your bulbs back?
Oh, that's fine. You can have them.
No, I've got a set over here. We just ran out of time, I've been told.
Can I ask mine? Can I ask
So
mine
we
anyway?
thank you very much.
We will have further questions and discussion out in the hallway, so you can keep discussing out in the hall. We're going to be changing setups, and there's two things happening at once. George Wiseman is going to be setting up for this afternoon at 1 o'clock. He's going to start his workshop, and then also while he's doing that, Dolores over here is going to be doing a short kind of informal presentation.